So the first one here, what is true about the hadron? Okay, so you remember that hadron consists of quarks. They are actually groups of quarks. So for question 2, what is not true about leptons? Leptons does not compose of quarks, because you know why? They are already the fundamental particle leptons. Okay, they don't. You cannot break down the lepton. So question 3, what is true about the quark? The answer is D, because there's no such thing as an independent quark. They're always grouped together to form hadrons. But hadrons can be further broken up to baryons and mesons. Okay, now, so for this question, possible composition of a neutron, remember it's neutral, so it's 1 up quark and 2 down quarks, so you get neutral. So the next question, number 6, so which of the following particle is responsible for carrying away the missing energy and momentum? Is actually a neutrino. Alright, that's why you will notice that the energy of the electrons, which in this case the beta or the beta plus, which is a positron, will always vary. Okay, because it carries, the neutrino actually carries some of the momentum and energy away. Alright, next one, question 7. So which one does not feel the strong force? The strong force exists in the nucleus, so it's between the quarks, between the protons and the neutrons. So what is not in the nucleus is actually your leptons, because those are not in the nucleus. So next one, which of the following particle is a hadron? Yes, it is actually a proton, because it consists of 2 up quarks and 1 down quark. So in the last question here, antiparticle electron is called a positron, because it's same mass but opposite charge. So next question, question 11, how many quarks? There are 6 quarks. Remember, you got up, down, charm, strange, top, bottom. Okay, all right. Next one, which of the following is an elementary particle? So elementary particle, next one will be electron, because it is a lepton. Whereas hadron are groups of quarks together. Proton are also groups of quarks called baryons. Neutron also baryons. So the only thing that's by itself is actually your electron. Next one, quark composition of a proton is up, up, down. Okay. So for question 18, what is the characteristics of neutrino? Yes, it has near zero rest mass. Okay, right. And for 19, which is following is an example of a lepton, is actually an electron. Okay. So for this question 20, what's the main characteristic of a quark? So obviously it is charge is fractional. It doesn't have zero rest mass, by the way. It has mass 1. Okay, and it's not a combination of baryons. Rather, a baryon is a combination of quarks. Alright, and it does not travel at speed of light. Only EM radiation does. So when we look at the table here, so proton is indeed a baryon and a hadron. Neutron also same. The beta plus, which is actually your positron, is actually a lepton, is an antimatter, and neutrino is just a lepton. Right? Okay. And for question 2, for each particle, give the quark composition or state whether it's a fundamental particle or not. So neutron is a composition of up, down, down. Proton, up, up, down. Now this is your beta minus, which is fundamental, and electron anti-neutrino, which is also fundamental. So for the next question, if you want to write an equation for positron decay here, so you need to state from proton, it becomes a neutron, plus positron plus your electron neutrino. Alright, and explain why of these reactions can only be mediated by the weak interaction, because the change in quark flavor, which is you realize from proton to neutron, you're going to change from 1 up quark to 1 down quark. So change in quark flavor involves weak interaction, right? So therefore you need the interaction to cause the decay. So in case you're wondering, so down quark to up quark in beta minus decay, and up quark to down quark in positron decay. Alright, and so neutrinos and antineutrinos are only affected by weak interaction. Right, next one. The equation proton equals to neutron plus positron plus electron neutrino is called a positive beta decay. Use the equation to explain why the neutrino can have no charge and very little mass. This is called conservation one. So electric charge was conserved in the decay. So when positive E charge on the proton, you have the proton here, positive E, and the positron also have positive E, so that means these two have no charge. Alright, and if the neutrino is charged, then they will violate the conservation of electric charge. Similarly, the mass of proton equals the mass of neutron, so therefore the positron must have very little mass. So the neutrino even smaller, because the positron is actually mass of electron, but the neutrino must have indeed a very, very small mass. Now, what are the differences between proton and positron? So proton is a particle, but positron is an antiparticle. There's one difference. Another one is a proton is not a fundamental particle because it's made up of quarks, but a positron is because a positron is a lepton. Proton has a mass 1U, but the mass of positron is about the mass of electron. It's actually mass of electron. Alright, so a proton is a hadron, but a positron is a lepton. State what happens in each type of beta decay in terms of the quark model. So in a positron decay, so you need to tell them up quark turns into a down quark. Alright, a positron and a neutrino. For beta minus, a down quark becomes an up quark, an electron and an electron anti-neutrino. So name the force responsible for the decay. Don't forget it's a weak nuclear force. So explain why a quark is a fundamental particle but a neutron is not, because a neutron is made of other particles which are your quarks, but your quark is already the most basic. A proton and a neutron each contains three quarks, so complete the table, right? So just write down. So proton, the charge is positive E, but neutron is 0. So proton positive E is actually up, up, down. Neutron is down, down, and up. Using information from the table, suggest why some quarks have a positive charge and some quarks a negative charge. For example, a proton is positive, so either one or both up and down quarks are positive. Alright, then only you can add up together to give you a positive lah. Alright, the neutron is neutral, so if one quark is positive, the other must be a negative. State what is responsible for holding the nucleus together is actually a strong force. So complete the table below. Electron is a lepton, neutron is a hadron. So another particle in the same group, so another type of lepton, you can put positron, muon, tau also can. Alright, neutron is a hadron, so another particle is a proton. Okay, so that's it. Right, the last one, the up, down, and a strange quark have charges 203e, negative 103, and positive 103e respectively. So what is the quark composition of neutron and proton? So that's straightforward. Up, down, down, and up, up, down. So just because the charges are like you can add up here and there, it doesn't mean it exists. So neutron must be up, down, down, and proton must be up, up, down. And you add up, then you notice the charge of neutron is neutral, 0, and proton will be positive E. For this question from the past year, so how many quarks, up quarks and down quarks must a proton contain? So very easy. So two up quarks will give you 403e plus one down quark, so is minus 1/3e will give you E, which is the charge of a electron, but it's positive. So you have to add this 2 with this 1. So answer is donkey.